topic. Okay, we will come to our topic. So that is designing of micro antenna. Okay, designing of micro strip antenna. Okay, so I will give you one task. Okay, so not now. Okay, so this one. Okay. Okay, actually this is your assignment. Okay, so this assignment I will give. Okay, and I will tell you how to do it. Okay, so here we have to design a patch antenna. In this, so the instructions are given to design the patch antenna. Okay, and so you have to simulate it with using HFSS. Okay, so you have to do this. Okay, so I will tell how to do this. Okay, how to design the patch antenna. I think, uh, are you familiar with HFSS? Have you done some project with HFSS?
Not sir.
You haven't done, no? So you haven't
Yes.
you haven't do the microwave subject, no?
Yes, sir. I not did that.
Okay, okay, okay. So don't worry, okay. So these are some basic design actually, okay. So in YouTube, okay, you can see how to design these things, okay. So so if you, so some easy steps there, okay. So it is not much difficult, okay. And also I also have some videos, I will upload them, okay. So you can refer them if you have any problem when you are going to design this in HFSS, okay. So uh, so this simulation, okay, this simulation, HFS simulation, you can submit later, okay. But this design you have to do first, okay. Design you have to do first, then you can do the HFSS design, okay. So I will tell you how to do the HFSS design. It is not much difficult. It is easy actually. Okay. So because maybe now we have only 4 weeks, I hope. Okay. So within that 4 weeks, I am not expecting this simulation. Okay. So after the exam, you can submit the HFSS simulation. Then you will have some time to work on this. Okay. On this HFSS. Okay. So you can submit it later, but this design you have to do and submit, okay? This calculation design you have to do, the microstrip design. Calculation you have to do and submit it, okay? Before the end exam, okay? So I will give you the, what is called the due date, okay? Then this simulation. The simulation you can submit later, okay? Don't worry, okay? Because the simulations things will not come to the exam, okay. But this designing things sometimes come to the exam, but don't worry, you no need to keep any of these equation in your mind, okay. But you should familiar with this equation and you should be able to use them whenever you need to use, okay. Okay, so we will see how to design microstrip antenna, okay. As I told you that microstrip antenna is designed in a substrate, okay, in a substrate. I show you a microstrip antenna, okay. So it is something like this, okay. So if I tell you, so it is something like this, okay. So you can see this is a substrate, okay? And this here you have up copper layer, and this is you have a bottom copper layer. Then in this copper layer, you can the microstrip designing you can do, okay? Then this will be the ground layer, ground plate, and here you have to connect the signal generator, okay? So that is how the structure, we can see the structure of a microstrip antenna, okay? So these microstrip antennas are available in our phone, in Wi-Fi routers, okay? In many places, we employ these microstrip antennas, okay? Okay. Okay, okay. First of all, you have to identify one thing, okay? You have to identify one thing, okay? So it is like this, okay? So you can see that here, the microstrip antenna is shown here, okay? Shown here. Yeah. Okay, so the mid exam, so we will take this as a mid exam, okay? We will take this as a mid exam, okay? We no need to have a mid exam because maybe time not enough to do a mid exam. But if you need the mid exam as a practice, if you need, you can request, then I can keep the exam, okay? In online, maybe online mid exam I can keep, okay? So I hope to give this assignment as the mid exam, okay? So anyway, you have to do another one assignment, okay? So one assignment you have already done, okay? So two assignments, another two assignments are given also, okay? So I hope one assignment is considered as a assignment, okay? Considered as a mid exam, okay? But if you need to write maybe as a practice before the final exam, okay, you can request, then I can arrange it, okay? So you can tell me later, okay? Okay, so okay, so you can talk with other student also, okay? Please talk with other student also, and just tell me the group decision, okay? Yeah, I can understand it, okay? So that is why actually I'm not going to have a mid exam, okay? Okay, we will start, okay? So, so you can see that microstrip line, microstrip antenna is shown here, okay? So it has a length and it has a width, okay? So, so you can see that, okay? The width is in Z direction, okay? And the length, this one length is marked on Y direction, and the X direction is the from ground to this patch antenna, that is the X direction, okay? So in X direction, we can define the what is called, we can define the thickness of the substrate in X direction, okay? So in X direction, in thickness direction, Y in length direction, and Z, that is the width direction, okay? So if you consider this kind of patch antenna, okay? So this is a patch antenna, okay? So I told you that the current distribution of the patch antenna is very complex. It is not easy, okay? It is not a simple thing. It is somewhat difficult, okay? So let's say that you are feeding a signal, maybe here, okay? Consider that this is your patch antenna, okay? So here you have the width and here you have the length, y direction length, z direction width, na? Okay. So y direction length, z direction, this direction from here to here. Okay. So that is the length. Okay. That is z direction. And this thickness is, the thickness is in y direction. Okay. So you can see that, okay, you can see that if we feed the signal using a signal generator, okay, using a signal generator, for example, this one is a microstrip, okay, this is a microstrip antenna, okay, this one also there, you can see, okay. I think it is not clear, okay. Okay. So this is our patch antenna, okay. Let's say that this is our patch antenna. Now you can see that we are going to feed to the antenna this way, okay. So here we have connected the signal generator. Actually, here it is not the signal generator. They have connected the what is they have connected? Can anyone tell what they have connected? What is this instrument? Can anyone tell? What is this instrument? If you have done the microwave, the student who has done the microwave subject should know this. This instrument we use to measure S parameter. What is that? The student who have done the microwave should know this. I think we have done one microwave practical also using this one. We have a small one. Here, this is a bigger one. Okay. In our campus, we are using nano level instrument. What is this instrument? This is a VNA, vector network analyzer. Okay. This is a network analyzer. We have a nano network analyzer, and we have done one lab using that one for the microwave instrument. Okay. So haven't you done? So this is the S11 curve actually. Here we can see the S11 curve for the antenna. Okay. We can see the S11 curve for the antenna. Okay. And in microstrip design also you have to find the S11 parameter. This curve you have to get in HFSS. Okay. So you have to learn that what is S11 S parameters. Okay. I think I have do a small introduction for S parameters. Okay. As I can remember. Okay. Anyway. Okay. So now you can see that this is the antenna and this is the feed line. Okay. So, so this is connected to the signal generator actually. Okay. So you can see that. Okay. So here we connect the signal generator. Okay. So this is SMA connector. I show you. Okay. So the inner pin is connected to this line. So that is the feed point. Okay. So signal is feed in here, and this outer part is the ground part. I think I have shown you. Okay. So this outer part is the ground. So that is connected to the ground plate. That means this bottom plate. Okay. This bottom plate. And the middle pin is connected to this microstrip patch antenna, this section. Okay. So the signal is given here. Okay. So when you are giving a signal, okay, when you are giving a signal, okay, when we are giving a signal, so this antenna will be excited, okay, and the current, some current is generated in this antenna, okay, current is generated in this antenna, okay. So it is happening that fundamental antennas also, in dipole antenna, in monopole antenna, micro infinitely small antenna, we got that effect, okay, and we derive all the parameters related with the antenna using that current distribution, okay. So the current distribution is somewhat hard here, okay, but using the current distribution, that current distribution also can be calculated using a technique. I can't remember that technique. What is that technique? Okay, it may be if we type it in Google, we can predict. Okay, how to this current distribution also you can calculate. Okay, but you have to use integration. I can't remember that. How to calculate the current distribution. Distribution in antenna, okay. So that is technique is called as so there are many things, okay, many approach, but one approach, there is a one standard approach. In MATLAB also you can use to calculate the current distribution. I can't remember, okay. Okay, I will tell you if I remember it. Now I can't remember it. Okay, so let's just forget it. Okay. So there is a way to calculate the current distribution of antenna. So I'm going to show you the techniques we used to get the current distribution of antenna. Okay. So anyway, so for micro strip antenna, it will be somewhat complex. Okay. So the derivation are also somewhat complex, okay. So anyway, here we have equation for the E field of the X direction of antenna, of the patch antenna. This equation give the X direction E field of the antenna, okay. So how the E field is changing in X direction. Okay, so this is given. Okay, so you can see that here there are some values m and n. Okay, m and n. Okay, so using this m and n, the mod are defined. Okay, mod are defined. Okay, so basically there are 1 0 mod and 0 1 mod. Okay, that means you can see that. Okay, so if you consider 1 0 mod, okay, the m is 1, z is 0. Sorry, m is 1, n is 0. Okay, so n is 0 means this part will be 0. So what is the value for? So this part will be 0. So what is the cos 0 value? Cos 0 will be 1. No? Cos 0 will be 1. Okay, so you can see that if n is 0, okay, if n is 0, only we have E naught cos M5LY. That means 5LY. Okay. Give me a moment. Okay. Okay. So you can see that. Okay. So if n is applied, this part will be cos 0. So it will be 1. Okay. So in 1 0 mode, if you consider only 1 0 mode, if you consider 1 0 mode, that means m is, this is mn. Okay. I forgot to tell you that. This 1 0 means m and n. So in 1 0 mode, m is 1, n is 0. Okay. So here, this one will be 0. That means cos 0. That will be 1. Okay. So in 1 0 mode, we have this E field. Mod cos m is 1 now. 5 divided by Ly. Okay. So this is the E field we have. Okay. Okay. Now tell me. Okay. Now tell me. So you can see that. Okay. So this is in Z direction. Okay. This is in Z direction. Okay. So that is the width direction. Okay. So now you can see that this part will be 1. This part will be 0 and cos 0 is equal to 1. Okay. That means in Z direction, in this direction, the E field is not changing. It is a constant. Okay. It is a constant like this. Okay. So E field is a constant. It is not changed. Okay. In Z direction, E field is constant because here this part will be 1. Okay. So E naught is constant. But in Y direction, that is the length direction. In this direction, okay, you can see that the E field is changing according to this one. Okay, E naught cos 5 by Ly. Okay, so this L is the uh, L is the length. Okay, length. That means this length. Okay, let's say that is this length is L. Okay, let's say that now you are going to feed the signal here. Okay, now what is this point? This point. If this length is L, so this one, this will be L.2 and this also will be L.2. So this will be L.2, L divided by 2 point. Okay. Okay. So what is the E field in this point? At that time, Y is equal to L divided by 2. That means half point. Middle of this patch antenna. Middle of this patch antenna, what is the E field according to this equation? middle of this Panchandra means L is equal to L divided by 2, half of L. Okay, the total length is L. So if you take the middle of this antenna, middle point, okay, so that Y is equal to L divided by 2. So what is the E field? Okay, so you can see that 5L. Now L is equal to L divided by 2. Okay, so 2 is going upside. L divided, sorry, 5L. L is constant. This Y is equal to L divided by 2. Now L cancel out. You will have 5 divided by 2. So Ex is E naught cos 5 by 2. This is the E field at Y is equal L divided by 2. This E field. Okay, so that is cos 5 by 2. What is cos 5 by 2? It is 0. Okay, so here in this point, the E field will be 0. Okay, and if you consider this point, okay, if you consider this point, let's say that, so now you can see that here you have Y, here you have X, and here you have Z. Okay, so this is Y is equal to 0. This is the point Y is equal to 0. This is the point Y is equal to 0. So what is the E field? X direction E field when Y is equal to 0. That means Y is equal to 0. Here Y is equal to 0. Now E naught cos 0. That means it is equal to E naught. Here, this E field is E naught equal to E naught. Okay. So once it's come to this, the middle, E field will be 0. Okay. Now, if the L is equal to L, that means in this field, this point, okay, so you can see that Ex is equal to E naught cos 5 by L. Now Y is equal to L. So L cancel out, you will have cos 5. So what is the cos 5 value? It will be minus 1. So that means if the E field is in this direction, now in this corner, E field will be in this way. Okay, so you can see that from here to here, the E field is gradually decrease and come to 0. And from here, E field is increasing, but other direction, like this. Okay, so that is mentioned here, E field distribution. So it is according to the cos function. Ex equal to this one. Okay, Ex is equal to E naught cos 5Ly. Okay, now you can see that. Okay, you can see that now at the input port, at the input side, okay, input side, E field is changed, and the other side also E field is changed. This side also E field is changed. So this side, this wall and this wall E field is changing, but this wall and this wall E field is not changing. It is a constant. This wall, in this wall it will be like this, because this way the E field is in this direction. So it is in this direction, and this line E field in this direction. So this point E field is this direction, so it will be in this direction. Okay, so this E field and this E field will not change. Okay, so if these are not changing, so from this wall there is no any transmission. The transmission is not happening in this wall and this wall. Okay, but from this wall and this wall, transmission is happening. Okay, so in 1-0 mode, okay, in 1-0 mode, okay, in 1-0 mode, okay, in 1-0 mode, in 1-0 mode, okay, in 1-0 mode, you can see that the transmission is happening, okay, from this way and this side. Okay, actually here the feeding, you are going to feed it here, you are going to feed the signal here. Okay, so that is 1 and 0. Okay, that means in length mode, in length, this is the length, in length side, length wall, the antenna is transmitted, okay? But this is the width, okay? In this width wall, antenna is not transmitted, okay? So that is 1, 0 mode. When it is 0, 1 mode, what happened? 0, 1 mode, what happened? Okay, so that is one question. You have to find the answer, okay? So that kind of question maybe will come to your exam also, okay? So related question, okay? So if you are given this equation, okay? So if you are given this equation, this is the E-field distribution of this patch antenna, okay? And for 1, 0 mode, when this M is 1, N is 0, you have to find the E-field of the antenna. So it is already found. And if it is 0, 1, you have to find what is the E-field change, okay? And you have to and also you have to understand in which wall will be radiating, okay? So you can see that in 1, 0 mode, only this wall and this wall is radiating. The wall related to length is radiating, okay? And in 0, 1 mode, you can understand if you correctly work on it, okay? This length wall, E field is constant, but this E field, this width E field, these are changing. These are changing. So the radiation happening in this width wall, okay? In this width wall, not length wall, okay? So actually this mode is dependent on that phenomenon, okay? So if you are going to input the signal in length side, okay, radiating is happening in length wall, not in width wall, okay? And if you feed to the width wall, width side, radiating is happening in width side, not in length side, okay? Right? So that understanding you should have, okay? Did you understand what I told you? Did you understand that one? Maybe you haven't understand it, okay? I feel that you haven't understand it, okay? Did you get the idea? And can we proceed for? Okay, quickly I will tell you again, okay? Quickly I will tell you again, okay? So you can see that here we are providing a patch antenna, okay? We are providing a patch antenna, okay? And patch antenna is named as Z direction is width, Y direction is length, and this height, thickness direction is X, okay? Then the E field of this X direction is given. So it is this one, okay? So E field is depending on this M and N, okay? So this M and N define some mode, okay? So let's say that if M is 1 and N is 0, that is 1, 0 mode, okay? So in 1, 0 mode, okay, E field is equal to this one, E naught cos 5 divided Ly, okay? Because this part will be, this will be N is 0, no? So it will be cos 0, so it will be cos 1, okay? So you can see that this EX, E field is only changing with respect to Y direction. With respect to Z direction, it is not changing. It should be a constant, okay? So it is changing in Y direction. How Y direction? It is changing according to the cos wave, okay? So this is L is starting from here. Here L is 0. At the middle, L is about 2. At here, L is equal to L, okay? So if you apply some value here, you can see that in direction, if this direction, E field is equal to E naught, okay? So that So when it come through this length, okay, when it come through this y direction, this E field is gradually decreasing, and at the middle it will be 0. Okay. Then from middle to L, it is increasing, but it is increasing in this direction. Okay, like this. Okay, at this point it will be again in this direction. Okay, here E field is in this direction. Okay, so in this world E field is constant because it is not changing. Okay, so E field, this point E field is this direction now, so here also in this direction. Okay, and here the E field is in this direction, so this whole direction like this. Okay. Now you can see that for a microstrip antenna there are 4 volts. This is 2 volts in W side. Okay, in W side, this one and this one are the 2 volts in length side. Okay, now you can see that in width side E field is constant, it is not changing. So you in this width side, in this width wall, there is no any radiation. Okay, there is no any radiation, but this length side the radiation is happening because in this wall the E field is changing. So the radiation is happening in this wall, L side wall. Okay, and if you consider 0, 1 mode, if you consider 0, 1 mode, okay, so that means it should be the vice versa. Okay, so in that case you have to understand it. Okay, in the same manner you can understand it. So this direction, this L side wall will not radiating because E field will be constant in this L direction, this Y direction, but this Z direction, E field, the XE field is changing. Okay, so it is transmitting only this Z wall. So that is related with width. Okay, so that is what I have explained. Okay, so you need to understand it well. All right, right. ඒක තේරුණා නේද කියප එක. දැන් මෙතන මේ E field එක තමයි අරන් තියෙන්නේ. හරි. X direction එකත් එක්ක කොහොමද E field එක වෙනස් වෙන්නේ? Y දිගේ Z දිගේ. ඒක තමයි මේ expression එක. හරි. එතකොට මෙතෙන්ට වැටලා තියෙනවා MN කියලා value දෙකක්. ඒ MN කියන එකේ mod select වෙන්නේ. අපි දැන් 10 mod එක ගත්තොත් එහෙම ඒ කියන්නේ M බිඳුවයි M1යි N බිඳුවයි. හරි. එතකොට මෙතන cos බිඳුවයි කියන්නේ මෙතන Z එක Z මෙන්න මේ direction එකේ E field එක වෙනස් වෙන්නේ නැහැ. E field එක constant. මේ පැත්තේ මේ පැත්තේ. Y direction එකේ කියන්නේ මේ wall එකේ තමයි E field එක වෙනස් වෙන්නේ. එතකොට E field එක වෙනස් වෙන්නේ නිකන් cos signal එකක් විදිහට. මේ පැත්තේ maximum තියෙනවා. ඒක අඩු වීගෙන එනවා. මෙතනදී මැදදී බිඳුව වෙනවා. ඊළඟට ආපහු වැඩි වීගෙන යනවා අනිත් පැත්තට. හරි. ඊට පස්සේ ආපහු මෙතනදී maximum වෙනවා. E note එක. හරි. එතකොට මේ wall එක ගත්තොත් ඒ පැත්තේ තියෙන E field එක මේ පැත්තට. මේ wall එක ගත්තොත් ඒකේ තියෙන E field එක මේ පැත්තට. එතකොට මේ E field එකයි මේ E field එකයි වෙනස් වෙන්නේ නැහැ. ඒ කියන්නේ මේ දෙකෙන් radiate වෙන්නේ නැහැ. මේ E field එකයි මේ පැත්තේ E field එකයි තමයි වෙනස් වෙන්නේ. එතකොට මේ දෙකෙන් radiate වෙන්නේ. ඕකේ අනිත් පැත්ත වෙනවා 0.1 ගත්තා. හරි. මේ scenario එක ඔකට identify කරගෙන තියෙනවා නම් මොකද ඒක design එකට ඕන වෙන්නේ. Okay? Okay. Okay? Okay. So now if you go to the design, okay, if you go to the design, so you can see that, okay. Okay, so this is the antenna, okay, and this is L side and this is width side, okay. This is L side and this is width side, okay. So you have to name this antenna somehow, okay. You have to position this antenna in the same manner, okay. So here the thickness is maybe in X direction, this length will be Y direction, this W in Z direction. You can name as it is, okay. And the dimension of this antenna is mainly dependent on the design frequency, okay. For example, this width is directly related with the design frequency, okay. So you are given the equation, okay. So this is in meter. Okay, so this equation is given. V naught is the velocity of the light. Okay, and this is the design frequency. Okay, this is the design frequency, and this is epsilon is depending on what? මොකක් මොකද මේ epsilon dependent? Epsilon r. Epsilon r කියන්නේ මොකක්ද? What is epsilon r? Now, if you understand previous week lecture, you should be able to tell this. What is this epsilon r? What is epsilon r? Please tell me what is epsilon r?
Dielectric constant.
Yes, dielectric constant of what? Of the substrate we are using to make this microstrip antenna. Okay, so there are different type of substrate. Okay, so here these some parameters are given. Okay, so I think these parameters we will have for Neltec substrate. Okay, for the Neltec substrate, the dielectric constant is 3.2 and the height of the substrate is 0.762 millimeter. Okay, so this is for Neltec. Okay, so Neltec board is given. Okay? So maybe for your design, maybe you are given another substrate. So there are another substrate also, FR4 and can't remember, there are some other substrate also. Okay, so maybe that substrate may be given. Okay, then this parameter may be somewhat changed. Okay, so you can calculate the width of the antenna. Okay, then okay, so I told you that for the microstrip substrate, effective antenna is different from the, if effective dielectric constant is the different from actual dielectric constant. So this equation is given. Using this equation, you can calculate if you know epsilon and if you know height and if you know the width. Now you are calculating the width. Okay, so if you know that width, you can calculate that epsilon effective here. Okay, then this epsilon effective is related with the length. Okay, so you can calculate the length using this one. Okay? And there is another part, delta L parts. Okay, so that is additionally introduce length from the fringing effect. Okay, I will explain what is fringing effect later. Okay, and I think you can see because there are some capacitors introduced in this okay, so that capacitor also will introduce some effect. Okay, so those are called fringing effect. Okay, so due to that fringing effect, okay, the length is somewhat higher than the actual value, so you have to calculate that effect length. Okay, so this equation you can use. W you have found, H you are given, and epsilon r, epsilon effective also you can calculate it using this equation. So this, using this one, you can calculate the delta L. Okay, the additional length due to the fringing effect. Then from the length you have to subtract two delta L parts. Okay, so that is how you calculate L. Now you can have calculated width and now you have calculated L. Okay, so now you can understand this width at L are not same. those are different. So this patch antenna is a rectangular patch antenna. So you will have a rectangle because width and L is different. Okay. And also we have consider this one also. Consider this one also. So here you are asked to design your antenna. Okay. It is not given. Okay. So you will ask to design your antenna for a certain input impedance. Okay. So it may be 50, it may be 100. Okay. Anything. So you will ask to calculate. You will ask to make this antenna for input impedance. Okay. Let's say that you are asked to find it for 50 ohm. Then to feed the signal to the antenna, you need to have 50 ohm microstrip line. Okay. So previous week we have discussed how to calculate. Okay. So actually this equation, can you use this equation to calculate this value? Can anyone feed? Can you remember what is this? Okay. This equation, no? This equation. Okay. So in this case, then antenna වලට ඔකට input impedance එක 50ට set කරන්න කියනවා. හරි? ඒ කියන්නේ ඔකට 50ක characteristic impedance එක 50ක line එකක් තමයි මෙතන design කරගන්නේ. ඒ design එක කරගන්න පුළුවන්ද මේ equation? Can we do that design in this equation? So we are given the characteristic impedance and we are asked to design the microstrip line. That means we are asked to calculate the width. Okay. So can we calculate that that thing using this equation? So is this equation is correct? Can we apply this equation? Okay, think it by yourself. Okay, think it by yourself. Okay. If you can apply this, you can apply. Okay. Do you have any answer for this? Just understand what is happening. Okay. Because yesterday, in previous week, we have discussed this. Okay. Okay. Now you can remember that. Okay. So there are 4 volts now. There are 4 volts. Out of 4 volts, only 2 volts are radiated. Okay. So that means 2 volts, 2 slots are considered as transmitting slot, radiating slot. Okay. So slot 1 and slot 2, these are identical. Okay. These are identical. Okay. And using this, you can calculate the conductance of the antenna. Okay. For that one, you have to calculate the total radiated power. Okay. So calculating the total radiated power is somewhat difficult. Okay. Because the current distribution is difficult. So that is this kind of one. Okay. So you have to do an integration. Okay. So this integration actually, it is very hard to do by hand. Okay. So this is we called sine integral or something. Okay. So we have tables for this one. This one. It is called sine integral. Okay. This kind of integration is there. Okay. So you have to use a table, sine integral table, but easily you can use MATLAB to calculate radiated power. Okay. I think for a design, we don't need to calculate the radiated power. Okay. But we have to calculate this G1. For that one, I think, yeah, we need to calculate the radiated power I4. Okay. Okay, anyway, I think here the I1, the current is also we can calculate it, okay, using this one. For this one also you can use MATLAB, okay, to find radiated power. Or this one you can use MATLAB, okay. So maybe MATLAB you can use, you can code this, okay. If you have any problem coding in MATLAB, you can contact me, then I can help you, okay. So try to code this in MATLAB using by yourself, okay. So if you couldn't, I will help you. So this is directly you have to code in MATLAB. So that is what happened, okay. So the limits are given, okay. So you will have a finite value here as I1, okay. So you can calculate I1, then using I1, you can calculate G1, okay. So that is the conductance, okay. And the R in will be the both slot conductance, that is G1 plus G12, okay. So G1 you have already calculated, then you have to calculate G12. G12, to calculate G12, you can use this one, okay. So this is Bessel function, okay. This also you can directly code it in MATLAB, very easy, okay. This one also you can code it in MATLAB. So try to code this. If you have any problem, please ask me, I will help you. Then you can calculate this G12 also, okay. Now you have to understand what is the mode, okay. So based on the mode, this plus or minus you have to select, okay. So the plus sign is used for mode with odd antimetric resonant voltage distribution in the slot, while minus sign is for mode with even symmetric resonant voltage of mutual conduction, okay. So, okay. So this 1 0, okay. So these are referred as odd and even mode, okay. As I can remember, this 1 0 is even mode, 0 1 is odd mode, okay. So there are two modes, odd and even, okay. So you have to identify whether, as I explained, okay, you have to consider the E-field distribution. You have to consider the E-field distribution. Then you can conclude this one is in odd mode or this one is in even mode. Okay. So based on that, you have to decide plus or minus you have to use. Okay. So it is based on the odd. Okay, 1 0 or 0 1. Okay. So just identify it and use the correct value here, okay, so that you can calculate the input impedance of the antenna, okay. So the input impedance of the antenna you can calculate, okay, and so you are asked to do the match the antenna to another uh, what is called another impedance, okay. For example, that may be 50 ohm, okay. So input impedance here may be another value. Let's say that it is 200. Now you have to match this 200 into 50, okay. For that one, you are using this small gap. This is we called insect feeding. That is also one matching technique, okay, okay. So to match that 50 ohm to this antenna input impedance. So antenna input impedance you have to calculate, okay, using this equation. You have to calculate G1, you have to calculate I1, then using the integration, then you have to calculate G1. Then G1 2 also you can calculate using this integration. So the Bessel function is also there. See how we can these are standard things, okay. So it is not hard to find in the internet, okay. So definitely you can easily you can code this, okay. Okay, just try by yourself, okay. Give a try by yourself. If you couldn't do this, you can ask. Okay. Then you can calculate G12 also. Now, based on odd and even mode, you have to calculate this. You have to consider this plus or minus value. Then you can calculate the input impedance of the antenna. Okay. So input impedance you will get. Okay. So the last part is, okay. So this is the given. This is given impedance. For example, this may be 50 ohm. Okay. And this R in this one. Okay. So you can see that. Okay. So this is Y0. You can see that this is selected as Y0. Okay. And here the Y0 is 0. And here, because it is, so this Y0 is in L direction. Okay. L direction. So it is in, as I can remember, it is Y direction. Okay. This L is in Y direction. No? So this is Y direction. This is X direction. So if you consider your origin is here. Okay. So this is Y is equal to 0 and this is Y is equal to Y0. Okay. So this Y is also is equal to 0. That is the impedance you are asked to match. Okay. So that will be 50 ohm. Or the given ohm, maybe 150. Okay. And here, okay, here the impedance is the input impedance of the antenna. Okay. Now you are going to match this input impedance to the desired input impedance. Okay. So that is, for that one, you are using this one. Okay. So this should be the desired impedance, for example, 50 ohm or 100 ohm, and this should be the calculated antenna input impedance. This one. Calculated input impedance, this one. Okay. So then using this equation, you can calculate the Y0 value, the length of the Y0. Okay. So you can calculate. Okay. So that is how you calculate this patch antenna. Okay. And also I will give you one question. Okay. In addition to that, what happens if we need to, how we can define, how we can construct a square patch antenna. That means this L and width should be same. So is it easy or is it complex? Can you verify? Can you understand it? If we are going to make a square one, okay, so you have to calculate this width and length should be same. This width and length should be same, but some problem is there. You can't directly calculate it. You can't directly calculate it. You have to get the simultaneous equation and you have to calculate it. Okay. So think that one also, why we can't, why it is hard to calculate the square patch antenna. Okay. Because L and width are not same. There are two different equations. Okay. So based on the width, the epsilon effective is dependent. And length is again dependent on epsilon effective. So width and length, based on width, epsilon effective is changing. Based on epsilon effective, length is changing. So what you have to do to avoid this? Okay, you have to do a simple mathematical things. Okay, so for this one, you can use your mathematical knowledge to solve this problem. Okay, so that problem also I will be given with the assignment. Okay. Okay, so now you have some task to do. Okay, I will explain that task. Okay, so for some tasks you have to think and you have to find the solution. And for something you are given, some task you are given, okay? And also you have to use your experience and mathematical knowledge also to solve some problems, okay? So I will upload this assignment, okay? Then you can do it and you can submit it, okay? So if you have any problem, we can discuss, okay? So we will stop the patch antenna part, okay? So the design is, you have to do the design, okay? I will upload the assignment in next week, okay? So if you have any problem, you can ask, okay? If you have any problem, you can ask, okay? And I think the attendance is not taken, okay? So please mark your attendance, okay? Then you can leave if you don't have any problem, okay? If you have a problem, you can ask me, okay?